Design Dropbox Google Drive by Nikhil Gupta. Overview. We all must have used Google Drive or Dropbox at some point in our life, or some of us may be active users of them at the moment of reading this article. Have you ever wondered how it works? How billions of data from millions of users across the world is managed by Google Drive? So see that we have here both a lot of users and a lot of data. So this is a combination, because sometimes we have a lot of data without a lot of users, sometimes we have a lot of users without a lot of data. In these cases, because it's Drive, then it's both a lot of users and a lot of data. In this article, we will discuss how to design a cloud file hosting like Google Drive Dropbox. Note, designing a drive is a very complex task and everything may not be covered in this article, but we will have a starting point and feel free to extend the design. Requirements. Functional. Okay, so this is the part where we describe the functional requirements. The non-functional are like latency, although latency we can say maybe it's part of the functional requirement. I mean, if the service does never come back, the latency is infinity, then it's quite functional, but let's split it. Functional. User should be able to upload photo files. User should be able to create, delete directories on the drive. 3. User should be able to download files. 4. User should be able to share the uploaded file. 5. The drive should be synchronized. The drive should synchronize the data between user and all devices. And 6, functional requirement is that user should be able to upload files, photos, even when internet is not available. And when internet gets available, then the offline files will be synced with online. Okay, so in general, we see here the main functionality of uploading, downloading, deleting files. We added here like a bonus of offline. Non-functional. Availability. Availability means that the percentage of the time the system is available to take the user's request. We generally mention availability as 5 nines, 4 nines, etc. 5 nines meaning 99.999% availability, 4 nines mean 99.99 availability, and so on. I think at this point it should be good to mention how many days. 99.9 is like 5 hours of downtime allowed. Durability. Durability means the data uploaded by the users should be permanently stored on the database, even in case of database failure. System, it's like partial database failure, because if there is a full database failure and the whole world database failed, then we won't be able to store it. So durability is like partial database failure. Our system should ensure the files uploaded by the user should be permanently stored on the drive without any data loss. Reliability. Reliability means how many times the system gives expected output for the same input. Scalability. With growing number of users, our system should be capable enough to handle the increasing traffic. ACID properties, atomicity, consistency, integrity, and durability. All the file operations should follow these properties. Atomicity, it means that any operation executed on a file should be either complete or incomplete. It should not be partially complete, i.e., if the user uploads a file, an end state of the operation should be either the file is 100% uploaded or it is not uploaded at all. Consistency. The consistency should ensure that data should be the same before and after the operation is completed. In databases, consistency means that the data makes sense. If I move a transaction, money from account A to account B, then consistency means that the actual money is moved from both accounts. And there is another term, the same word, consistency, is also used on the triangle of availability, consistency, and network partitioning. Over there it means something else. Okay. means the file that the user uploads should be same before and uploading the file on drive. Isolation, this means the two operations running simultaneously should be independent, not affect each other. Durability, already explained above. Capacity estimation, let's assume that we have 500 million total users, out of which 100 million are daily active users, which means we will have on an average 0.07 million active users per minute. Let's assume at peak we will have 1 million active users per minute. Assuming on average one user uploads 5 files, we will have 5 million uploads per minute. If one upload is on average 100 kilobytes, then the total data uploaded in a minute will be 500 terabytes per minute. This gives us the picture about how much data we have to store for all our users. API, upload file. So here we see a post request to upload the file. We see the response, the file name, the created on date, the response. The uploaded file will work in 2 steps. First, the file metadata will be uploaded to the server, and then the file upload process will start. Download file, get file, response, we get a file ID and the download URL. The URL provided by the backend will be used to download the URL. It can also be used to share the file into other users, and delete file ID, get latest snapshot, /folders, /folder ID, start index and limit, and this will return a list of file, each file with the file ID, file name, thumbnail, last modified. The snapshot API will give the list of files present in the folder. It may happen that folder is having too many files. In that case, we have to return the paginated result and load the data as users quotes. Design considerations. File storage for users. We want highly available and durable system to store the user uploads. For this, we can use AWS S3. S3 is highly available and durable service offered by AWS. S3 bucket does not have any limit to any storage capacity, and the max object size it can store is 5 terabytes, which is way more than most of the devices currently used. Storing user data and their upload metadata. To store the user data, file storage and users, we want high available and durable system to store the user's upload. For this, we can use AWS S3. S3 is highly available and durable service offered by AWS. S3 bucket does not have any limit to any storage capacity. The max object size it can store is 5 terabytes, which is way more than most of the devices currently used. Storing users' data and their upload metadata. To store the users' data and their files metadata, we can use a non-restrict database like AWS DynamoDB, which offers high available and reliable. Offline updates. When a user's device is offline, all the updates done by a user will stored on their local device storage, and once the user comes online, the device will sync the updates on the cloud. Uploading files. The size of the uploaded file by users can be huge, and to upload the file from any device onto the drive without any failure, we have to upload it in parts. For this, we can use the multi-part upload feature provided by S3. However, the multi-part feature will be used in file upload service to upload the file to S3 bucket, but to transfer the file to the upload service, we need some kind of small packet-based uploader at client device application as well. For this, we can build a custom library that will divide a large file into small packets and upload the packets into the service. We can design the library such that it would be able to upload multiple packets simultaneously, and file upload service should be able to collect packets and upload to S3. Downloading, sharing files. The files will be shared via S3 pre-signed URL. You can read more. Sync between devices. When a user makes a change on one of its devices, changes should be reflected on its other devices. When the user logs on to other devices, there can be 2 ways to do it. As soon as the updates from one device, the other devices should be updated, update other devices when the user logs into it. We will go with the second approach. It will prevent unnecessary updates to other devices, even when the user is not on other devices. Now we have discussed the use cases when user is logged into the device. What if a user is online on 2 different devices? Then in that case, we can use long polling. The device, long polling means the device opens a connection and basically the server doesn't answer. You make an HTTP request, you don't get the answer from the server unless you have an answer. When you have the answer, you answer and close the connection. The device in which the user is currently online. So long polling is like long polling once. This is in opposition to server-side events where continuously sending data from the server. The device on which the user is currently online will long poll the backend server and wait for any updates. So when a user makes an update on one device, the other device will get updated. Database design, user table, user ID, user name, email ID, creation date. Metadata table, field, user ID, file name, file location, create, HLD. Okay, so we see here the user device, contacting the file upload service, the file metadata service, and the synchronizer. Component details, file metadata service. This service will be responsible for adding, updating, deleting the metadata for the user uploaded files. The client devices will communicate with this service for metadata of file folders. File upload service. This service will be responsible for uploading the file to S3 bucket. User's device will stream the file to this service in chunks, and once all the chunks get uploaded to the S3 bucket, the upload will be completed. Synchronization service. There will be 2 situations where we need to synchronize. One, the user opens the application with its device. Then in that case, we will sync the user's device from the synchronization service with the latest snapshot of the directory user currently viewing. When user is online from a device and there may be possibly that user updates the drive from another device, then in that case, we need to sync the user's first device. So for that, we can use long polling again. To poll for, basically we do a long polling, meaning a request from the client to service. The service will return a response only when finished, only when it has new data. For that directory, lazy sync with long polling. S3 bucket. We are using S3 bucket to store the user's files folders. Since there is no limit to bucket size, we can create folder based on user's ID and files. Folders for each user, which can store in that user folder, DynamoDB. This database will be used in storing the user data. I would even use SQL here. File metadata as per the data design explained above. For users metadata, SQL could do a good job, even for billions of records. Cache. We are using because it's small data. We can index it. It's okay. Cache. And also in users data, we are doing searches for data. If it's content that we are presenting to the user, then DynamoDB could be good. Cache. We are using cache to reduce the latency for metadata retrieval. When the client requests the metadata for file folder, it will first look into the cache, and if not found in the cache, then it will look in the DB store in cache and return the result. Load balancer. We want our service to scale for millions of users. For that, we need to scale our services horizontally. We will be using load balancer to distribute the traffic to different hosts. User's device. Users can have multiple devices like mobile, desktop, tablet for accessing the drive. We need to ensure that all the user devices have the same data and there should be no data discrepancy. Bottleneck and feature extensions. Sharing folder for other users. We covered sharing files to other users. What if a user wants to share the folder and other users should be able to view the folder and its subfolder and files? Okay. 2. Permissions-based sharing control. This will allow users to share the file and configure what other permission should be allowed, like read-only, writing, etc. 3. Make user data secure. As of now, we haven't talked about how we can secure the user's data. Since we do not have control over the data user is storing, we need to assume that every data user stores is very critical and should not be leaked to unauthorized persons. There can be a lot of extensions and improvements possible for the current proposition design. Feel free to drop your suggestions in the comment box. Hope you find this article helpful. Keep watching the space and follow more of this future article, as this was a good one. Let's give him some claps. Where are the claps? Here. Okay, so this was Design Dropbox Google Drive.